Okay, so here is the Denodo screen where you have a lot of data sources which are supported out of the box. You can see multiple databases. You have Hadoop over here. You can connect directly to Amazon. Even multiple Hadoop databases too, like Bhala, Hive, and all that, but also to plain old HDFS file systems if you wanted to. SaaS, web services, which can be REST, SOAP APIs, legacy applications, and so on. So in this case, I've already got an online. In the demo, I said I'll join online customer with orders. So this is a online order, and each one of them is actually it's not a simple. I'm using views that have been created by somebody else before. I can show what this view is, which by itself is also joining multiple different databases and tables together. But I'm going to use that, since it's already been done by somebody else, I'm going to use that same view and create another view on top of that. Join these two on customer code. Sorry. And then use one of the product dimensions. And this product dimension is from an MDM system, actually, which again itself is not just a select star from one table. We'll join that to product, and so that's a join right here. And you can change in this. You can change. There's a lot of things you can do in Denodo. You can change the joins, the inner, outer, and so on. In this case, I'll just keep it a simple inner join, and the model will save this off. And what I want to show you was the actual back and what it does in the back end to join different databases and tables. I may make it slightly bigger for you guys. Sorry. So in this case, it's joining SQL Server, MySQL, and there's an Oracle database somewhere here. Find it, but as you can see, it's many different tables, and you can join multiple databases and multiple tables in there. You can obviously have lots of options, and I mean, to learn more about this, I mean, the Denodo website has a very good description of this. You can specify how much memory you want. Do you want to cache it? You can actually cache these views, partial caches, and so on. You can index the views if you want. There's quite a few things you can do, and it also shows you what the execution plan is in terms of the. Oops. I just clicked on the execution plan right here, and it shows you what all it needs to do in the background to actually optimize the query plan, which is extremely important for especially in a distributed sense. So this view has been created, this order returns view. What I'm going to do is shift to a command line here. I'm going to register this view. It is as simple as registering the name of that view right here, and then I'm going to train the view in terms of what models I want to use and what I want to predict in terms of the in the predictors, which is So in terms of this, what I'm going to run is a few commands. Typically in a customer, these are all something that data scientist does. Like I mentioned, they have to be programmers in the project, so most of them are used to things like this. I'm trying to estimate, predict profession and marital status based on the attributes here, which are age, product type, gender, and so on. I'm going to just run that. The first time it runs, it actually takes about a few seconds, hopefully, to start up. So wait on that, and it's reading the actual online view that we actually just created, which is the order returns view. You can see that right here. And then it's going to start from the estimators that we gave it. It'll create a bunch of different sets of estimators to actually look for in terms of predicting marital status or profession. So it's in this case it's generating combinations of length 5 from this set that we actually passed in, and it's trying to predict profession using. I just took the 6 or 7 of the models that we have here, and I'm not passing any parameters in this one, but parameters can be passed too. So while that's going on, this is being logged to a dashboard, and I'll show the dashboard in just seconds. Again, it's doing profession based on these attributes now. These are the 4 different attributes. So we gave it a list of 5 attributes, and it's choosing combinations of 4. And then after that, it'll do a combination of 5 which is only one combination for the profession. And while that's going on, I'm going to show in terms of dashboard, in this performance panel over here, it shows what models it used for doing professions as well as marital status, and what are the predictors, what the score was. There are quite a few attributes, a lot of attributes in the data, the control tables and the data mart behind this. We're just showing a few of them over in the dashboard, but there's a whole historical stats of what needs to be done. And at the bottom panel here is the sample history, which is all the samples that were done for different views from Denodo, and what the population count was. And so any of these samples can be used for any of the models to be scored. And you can obviously filter on these models and select them. So after that one is done, we'll show the model prediction, which is we'll show you right after that. I'm going to run it again, but this is the one I did right before this webinar. In terms of the actual prediction, try to predict. There were a couple of things I want to show you right here. Is you can see here it says no model instances scored, or in this case right down at the bottom here it says out of all these 6 or 7 models, 3 of them actually had a score of more than 0.66, 0.6, which is our threshold. We can have a threshold of 7, 8, 9, 5, whatever the team wants to do. And so of all these models, it's actually just storing only the models that scored above the threshold. And so those are the models that are available in the dashboard for scoring. We can store all of them if you set the threshold to 0, but that means those models were not really doing anything. I found 0.8 or 0.9 to be better, but for the demo, since I wanted to show more than 1 or 2 over here, in terms of being stored, lowered the threshold to 6. So next, using the same model, so this is a model that we are trained and now it's stored in the database or in the framework for modeling. The whole model itself is actually stored as in a file or in a database as a model, which can be then used for scoring. Next, just score I'm going to show that I want to score marital status and profession based on these and come up with results using the same model that was just now trained, as well as the same view that was created right now in Denodo live. As opposed to the samples I'm using here are online samples, not stored samples, but we can also use stored samples. So it's going to start scoring now, marital status based on these estimators, and start logging the data to this report here, which we can then after that's logged here, we can figure out if there's anything of interest in terms of what is predicting. So you can predict when we're student. So these are all the from these estimators, from city, age, and product line, we estimating what the profession was based on the orders in the orders on the orders table. And then the background here, it's basically scoring. And the scoring is pretty fast actually. And right now, the demo machine is only running on a 4-node CPU, but typically you can deploy it on a large number of nodes. And so this is the dashboard that the data modelers or the data scientists can actually look in terms of the actual online scoring, which can be then used for figuring out if your model is performing well or not. So in terms of, that's the end of the demo. I'd like to go back to the key takeaways. So in terms of the key takeaways, what we saw was that automation of the data access, as in we created a view in Denodo and used that same view to then create, to train the model and allow it, and we reused 3 of the views that were created before. Customer view, the order view, and the product view, and created a new view on top of that. So it showed basically a reuse. And the virtual piece in this whole thing is those views we did not sample at rest data. There were live data from the actual tables in actual app. It can be application, but actually tables in production. So it was not some data that we landed to disk somewhere and tried to use. It was real live data. Then we showed the tracking of all the results that we were doing, and also the tracking of predictions for the same model on the same view without changing anything in the data pipeline. We developed the model as well as code the model without changing anything at all, which is very key in terms of the virtual engine of in this framework. And in terms of that's a key takeaway, I think, in terms of efficiency in development and deployment. Is we want to automate a lot of the development and want to automate, completely automate the deployment if possible.